Hey everybody, my name is Mark Atherton with the Sporlan division of Parker Hannifin. Glad to be a part of the NAASRC Summit today. We're going to be talking about Microthermo Alliance and the Transcritical CO2 control solution for Microthermo Alliance in food retail. So this is me over here. This is a bit of a dated picture. I've lost the battle with male pattern baldness. So just imagine this, but gone. Like if this guy went as Telly Savalas from Kojak for Halloween. So that's me. Like I said, we're with the Sporlan division of Parker Hannifin. So Parker Hannifin is the global leader in motion and control technologies. The Sporlan division is a veteran in the refrigeration HVAC industry. We manufacture mechanical and electromechanical control valves, contaminant controls, electronic controlled, and they're headquartered out of this building here on the left, which is Washington, Missouri. Within the Sporlan division, we have Microthermo Technologies, which is the Microthermo Alliance platform that we're going to be talking about. This location is just outside of Montreal in Mirabel. And then not pictured here is the refrigerating specialties portion of our business, which is located in Broadview, just outside of Chicago. And we manufacture large industrial ammonia valves at that plant. So what are we talking about today? Today, we're talking about Transcritical CO2 Stores. And I guess to talk about Microthermo and Sporlan's experience with Transcritical CO2 Stores, we have hundreds of installations in the United States and Canada. We've been doing this for the better part of a decade. When I say in the United States and Canada, I mean everywhere in the United States and Canada, from the coldest regions in northern Canada all the way down to Texas. So pretty much all climates. We've done systems with pretty much every case and rack manufacturer out there, all sorts of different system designs. So we have a whole lot of experience controlling CO2 in various climates and in various system designs. So just talking about it from an end user and service standpoint, what's the value? The value of Microthermo is saving at least 10% of energy on system energy for refrigeration, which is a big deal, especially with transcritical CO2. And the reason for that is obviously the warmer it gets, the less efficient transcritical CO2 systems tend to become, and those energy bills can get pretty significant if you don't have the correct control out there. And it's pretty easy for people to say, hey, we'll save you 10% on this or 15% on that. You know, not only did we prove it out in a lab first, but where we really hang our hat on this is this has been vetted by multiple national retailers that have put us heads up against competitors in equivalent climates with equivalent systems. The only thing changing is the control system, and they have verified off of their utility bill at least a 10% energy savings. On the service side, saving up to 20% on startup and annual service costs. And this is, you know, obviously all geared towards your service technicians. How are we able to do that? A lot of this really revolves around the annual service costs and a lot of the history and graphing that you're able to do within Alliance. And also, anytime if there were ever to be an issue on a control board anywhere out in the store, you can replace it super simply. You should never have to reprogram anything. It should just be an easy service pin swap. And then on the food loss portion, reducing shrink by 10%. So how do we do that? We have some really cool alarming parameters we'll talk about later in this, some cumulative alarms which can look at food degradation because, you know, obviously shrink is a big problem. Nobody actually wants to throw out food, but in addition to that, food quality is a huge deal, which also gets affected. So you may not necessarily have to throw it out, but we also want to preserve food quality as well. So if we look at it from a store solution, so Microthermo Alliance controls the refrigeration system, can also control HVAC, lighting, any sort of, you know, backup generator, anything else you want to program. Today, we're just going to be talking about transcritical CO2. So if you were to look at a standard transcritical CO2 installation, it would look something like this. Let's just start over here at the flash tank. All right, so we're feeding liquid off the bottom of the flash tank coming through to your evaporators. You got a medium temp, low temp group over here. Just to show you guys, we can run pulse valves on this. So our standard case controller would be controlling all the functions within the case. And the primary function obviously is that metering device, so that expansion valve. And that expansion valve could be set up as a pulse valve or a standard stepper valve, so our SPW pulse valve here, or SER or SSER bipolar stepper valves. Then in addition to that, the case controller is going to be controlling the rest of the case functions. So lights, fans, anti-sweat. If you continue scooting down the system, you don't have to, but in this case, if you were to use CDS valves or EEPRs on this, you're going to have those controlled by a circuit controller. Keep on scooting down the system, you've got a rack controller, which is going to be controlling all of the rack functions. So this is going to be compressor staging. This is going to be your oil and oil safety, any safety line alarms out there. Anything having to do with your rack is going to be controlled off of this train. And if you continue following it up to your gas cooler and any heat reclaim, you've got a condenser gas cooler controller, which is going to be controlling your high pressure valves. So our GC series of gas cooler valves and flash gas bypass valves, as well as any heat reclaim that you may have, either for space heat or hot water heating. So those are the way that the system would typically be distributed. And like I said, this is just for the refrigeration portion. You're also going to be tying in store ambient, store outdoor, and then you'll take all of this information and network it into a data logger, which records all of this data for 5 years and gives you a user interface. And you can use pretty much whatever interface you want. You can use a touch screen, you can use a flat screen, you could parallel port it into something in the manager's office, you could put it up in the motor room. We're super flexible on that. In addition to this, we have free topology echelon network wire, which connects all this. So these are these orange lines you see running around. So we have a free topology echelon network that ties everything together. And the cool thing about this is, being free topology, if you've got a store and you need to do a remodel or retrofit, you need to add a case, you need to replace the lineup, you don't have to look for the end of the line. You can star, bus, tap wherever you need to off of this network. So we keep on chugging through here. Like you saw in this last slide, we'll back up real quick. These are the modular sets of hardware on the different trains. And what that is a communication board up front, and then modular hardware for whatever you need to control connected after that. So that could be relay outputs, it could be valve drivers, could be universal inputs, could be analog outputs. So whatever you need for any given application, you snap on. So you just have one set of hardware that can be used pretty much anywhere in the system. One of the great things about it, like we said earlier, you're strung together with that network, and there is no one single point of failure. This is a distributed control system. So you could go in and cut the network wire, and whatever train needs to be doing that command, or that case controller that needs to control that case, the logic is done locally at that controller. So it is going to continue performing its task until the network can be reestablished. It's not like the whole store shuts down. There's no one main controller that everything dies. It's a distributed control system that can act independently. In addition to this, with those applications you saw with the 3 different trains, we also have the UC700, which stands for Universal Controller, which allows you to write custom applications. So if you have a specialty application that we either don't have a canned application for, or something really odd, we've done all sorts of weird applications. So that's something else to be aware of. On the case controller side, we mentioned case controllers earlier, being able to drive stepper valves or pulse width modulation valves. And you can do a standard case controller will have a bipolar stepper driver output on there for an SER or SSER. If you want to use pulse valves, we have a case controller that actually has 3 pulse width outputs on there. So you can run just one in a case, or if you have a 2-coil case, you can run 2, or if you have a 3-coil case, you can run 3. And so that's running 3 of those Sporlan SPWs. You can do standard superheat control. So if you had, say, an EPR that's doing the case temp control, and all you want to do is control superheat, you could tell the case controller to do that. It's got a low superheat limit built into there to make sure that we protect those compressors. Or if you didn't want to have an EEPR and you were able to just run an electronic expansion valve to control case temperature, you can do return air, discharge air control on there as well. So what really sets this apart is a lot of the things that we do. We've spent a lot of time on this case controller and given you a whole lot of options to tune it. We have all sorts of things, whether that's environmental correction factors that take into account relative humidity and space temperature, night setback features if you have night curtains. We have built a lot of this into the case controller to make sure you have the optimum control. From a software and security standpoint, so like we talked about, Alliance has the ability to not only control refrigeration, but also HVAC and lighting and any other subsystem you may have tied in on there. Because of that, you could have multiple people in here. I mean, if you look at it from a store manager perspective, you might have one company taking care of HVAC, a separate company taking care of refrigeration. So we understand that you may want to have multiple people that have access to your system, but you may want to safeguard which parts of the system they have access to. So we have multiple permission levels. So not only can you segregate by subsystem, but also whether you want somebody to just have overview of what's going on, maybe some store personnel would just have overview, and then, your standard technician would have maintenance privileges, so he can throw things into defrost if he needs to. And then you have the configuration mode, which basically allows you to change anything you need to. So we can segregate it by either systems or permission levels or both. One of the wonderful things about Alliance is that all of the changes in the system are tied to that user. So there is no backdoor. Everybody's got a username and password and permissions that go along with that. And every change that individual makes is logged with their username and password and a time and date stamp of when the change was made and to exactly what it was changed to and from. And then we retain all of that for 5 years. So not only do we retain a 5+ year history for all of the changes made by users, but we retain a 5+ year history for every single point in the entire store. And so that's everything. That's all temperatures, all pressures, all status of lights, fans, compressors, unloaders, VFD percentages, any alarming history, anything that went into fault, came out of fault, anything that happens in the store gets retained for 5+ years, which is massive when you're doing triaging and taking a look at the store. If you're considering doing retro commissioning, any of that is super helpful to be able to have that history. And the last thing is the remote access, right? Which is huge. I cannot tell you how many times we have people who are able to diagnose system issues in a store before they even get out of bed. They pull it up on their phone, they can take a look, they know what they're going into. It saves a truck roll or a trip to the supply house because they know what they're getting into before they even get to the store. If you were to look at this from, let's take a step back. Let's say you're a store manager or you're a service technician. Something you'll see about Alliance is that it's extremely simple and it's a graphical user interface. And the reason we did this is because we designed the graphical user interface to be helpful for just that, for the store manager, store personnel, or the service technician. Because you got to realize that service technicians, A, there aren't enough of them, sadly, and B, they've got a lot of stores to cover. They may have never been to the store. So let's say a service tech walks into this store. They've never been here before. It's their first time. They got a service call. They need to check something out. What we've done is when you take a look at Alliance, you can put any background that you want to, any picture that you want to, and then populate it with any information that you'd like to do. So one of the things we commonly do is put the actual store footprint. So we'll just take the architectural drawings and we'll drop that as a background. And then we will put all of these little indicators on different cases or points of interest. And we've gone with a very simple green is good, red is bad, just a stoplight strategy on that one. So as you can see, pretty much everything in the store is green, except for a couple of these orange ones right here. It just means something's currently in defrost. This little red guy up there was a door ajar alarm. You can't ever convince people to close the door. But right now the store is looking good. Everything's green. Let's say you wanted to take a look, right? Because just a green dot doesn't show you a whole lot. So this entire floor plan is scalable. So when you click on it, it's going to zoom you in. And so now we've just zoomed in. Okay, awesome. It's some ice cream freezer door cases, a little end cap, a little dairy end cap over here. And now not only can you see what it is and what temperature it's at, but you can see that it's also green, which is fine. It means that nothing's currently in alarm. So if you click that again, it's going to bring you directly into the case controller plugin. And this is, I cannot overstate this enough, how powerful that is. You have gone from a floor plan of a store you may have never have gone into. You don't even have to know what the case circuit name is. You just have to know where it is in the store. And in 3 clicks, you can be brought into the case controller where you see the valve percentage of opening, what liquid pressure and liquid temperature you're feeding it, the evaporator pressure and evaporator temperature coming out of the back of it. We'll even do a superheat calculation for you so that you never have to talk to tech through how to calculate superheat. It's already done for you. We're giving you space temp, relative humidity. Go ahead and translate that over to a dew point, and then tell me what percentage we need to run our anti-sweats based off of that. What's going to be our control temperature? Are the lights on? Are the fans on? If I need to do any sort of overrides, be it lights, fans, anti-sweats, you do an emergency defrost, we want to override the valve to be 100% open or to be 0% or 20%. You can get all of that information from a single screen. And in just 3 clicks, you can get here. If you want to take it one step further and pull some trend graphs to see what's been going on, let's say you're potentially trying to diagnose an issue. All right, all you do is click on trend graphs and it brings you to a trend graph. Not only is it the graph that shows you the high limit, the low limit, and the proposed control temperature, but also you get a description of the most recent things to happen on this case. Actually blanked out the usernames, but you'll have timestamps, usernames will typically be there when I don't clear them out for presentations, in the description of what happened. Not only that, but this is where you can come in and you can look at the historical times. So you can go back to any date you want to. And let's say, all right, it's great that I've got this information, but I'd really like to take a look at a couple other temperatures and pressures. Great. You can graph any point in the system against any other point in the system over the whole 5 years. So you can go back to any day and pull any point and graph it against any other point. So let's say in this case, you wanted to take a look at your case temperature versus your valve position from a percentage opening standpoint to the superheat that you've got coming out of the back of the case. That now we've gone from 3 clicks to get to a case controller to like 5 clicks to be able to graph pretty much any point against itself at any point in time that the store has been running over the past 5 years. So from a technician troubleshooting standpoint, this tool is massive and it is extremely, extremely simple to use. So talking about simple to use, case controllers are fairly simple. Racks can get complicated depending on what the system design is. And so I'm sure you guys have been in motor rooms in the past where you've got 3 or 4 racks and there's almost no documentation left, and you've got people who have written on Sharpie on the side of panels the last time they changed the filter dryers or topped the receiver off or added oil or did whatever they needed to do. It would be super nice if somebody had a handy schematic of exactly what's going on currently, real time, with all of the information. And that's exactly what we had here. So Sear Squared actually did this project where it was fairly complicated, and they said, you know what, we want to make it simple to walk through this fairly complicated system. And so they put the whole rack on a page. It's the same green is good, red is bad mentality. You can take a look at anything you want to related to the system. So you've got all these compressors. If you zoom in, you're going to see that some of these dots are going to be unloaders. Some of these dots are going to be oil solenoids, whether they're going to be feeding or not. There's VFD percentages. You can look at valve percentages. All of this right here is interactive. You can click on it, and once again, you can get the 5-year graphical history. So this is just showing you that you can lay out your motor room any way that you want to. You can make it look like whatever you want to. The easiest way for your technicians to service the store, we can set it up. Getting into some other custom views, this is, obviously this presentation is geared towards food retail, but we've also done cold storage, industrial processes, ice rinks, breweries, all of which with transcritical CO2 systems. This one wasn't a TC CO2 system, but this is actually an oil field workboat service vessel where we control the refrigeration system and a bunch of chillers on board. So you can make the background look like whatever you need it to make it as simple as possible from a service standpoint. Some of the food quality alarms that we had talked about earlier and wanted to run through real quick. Typically, if you think of alarm, you just have a threshold alarm, right? Like, hey, if we get above 40 2 degrees for X number of minutes, we want you to throw alarm. Or if you get above this alarm at any point in time, we want you to throw a high limit alarm there. And that's how most alarms work. And they work fine as a threshold alarm. But if you want to get into performance, not just, hey, we're about to have ice cream melting. If you want to get into true case performance and tuning, one of the things that we like to do is a set 2 alarm, and you can have an accumulative alarm, which basically calculates the amount of time you're outside of the region you want to be. So I don't know if you guys can see it, but there's a fine red line here for the high limit, a fine red line here for the low limit. And what this graph shows is that even though this has gone over the limit, it hasn't stayed over the limit long enough to actually trigger a set 1 alarm. But this set 2 alarm, which is the cumulative alarm, was triggered, which basically meant, hey, we tallied up the time that we spent outside of this window. And so if you wanted to set it up where it's like, hey, if we spend, 4 hours or 6 hours out of the temperature range in a 24-hour period or 48-hour period, whatever time window you want to, we need to go ahead and throw an alarm, because it doesn't necessarily mean that we're going to be throwing food out, but it means that something isn't running the way that it should be. And you can set these up for all sorts of things, not just cases. And so that's something that we've used that really, really helps dial in case from a performance standpoint and from a food safety standpoint. Also to mention real quick, we do alarm monitoring. So we offer comprehensive 24/7, 365 monitoring service. So any microthermal systems, we can dial in, take a look at it, whatever you guys want us to do on that from a triage standpoint, email a list, phone calls, remote monitoring. It's completely covered, whether you've got 10 stores or 1,000 stores. And appreciate y'all's time. If you guys have any questions, by all means, don't hesitate to reach out. My email is mark.atherton@parker.com. Enjoy the rest of the show.